Okay, honestly, when I typed this lab, it kind of made sense as I typed it. When I read it over the first time, I thought, oh, yeah, we're good. That makes sense. But now that I've kind of moved away from it for a couple weeks, when I come back to it, I'm not so certain that it's clear. So hopefully this video will clarify what I'm asking you to do in the lab. First off, it is a lab, but unlike some like chemistry and biology labs where you got like this purpose and hypothesis and all this other stuff to follow, this is a physics lab in which it's more about the method and the problem solving. So there's no, well, I'm not worried about you repeating back the purpose and the hypothesis and the method and all the rest of it. This is a lab, it's more of a problem solving exercise. I'm going to give you a problem to solve, basically some physics things I want you to solve for, but I'm not going to give you a clear procedure on what you got to do to get there. So as you work through this, when you're ready to turn it in, make sure that you've kind of told me what you did and why you did it. Um, Before jumping in, maybe spend some time thinking about how you could answer these questions that I asked you. Um, I've given you some resources. Unless I've goofed up, and I'm confident I haven't, normally in an open-ended lab, I'll have given you all the numbers you need. It's just a matter of you finding them and working them through. Okay, having said that, so that's just the background or open-ended lab. Think about what you got to do, see if you can do it, ask questions if you can't, but in theory, everything is in this document that you need to answer these problems. What this lab is if we were in school, we would do it together. I would give you carts and tracks and things, and you're going to have a cart roll down a track, and then it just comes to a sudden stop at the end. We don't even care about that. The point of the end of the track, it's an inclined plane, is to get the cart moving. So the one end is high, some gravitational energy, the other end is low, and the cart starts rolling down there, converting to kinetic energy. What I would like you to figure out, I've typed it on here a couple times, is I want you to tell me the loss of energy, how many joules the cart loses as it rolls down the cart. And then one step farther, could you figure out the force of friction acting on the cart while it rolls down the track? And then a bonus one, because we're not really going to talk about efficiency this year, could you figure out how efficient the track was, the inclined plane was at getting the cart moving? All right, there's pictures and videos there, but I'm nervous that maybe it didn't come out as clear as I wanted to, so I'm going to doodle a little picture. Um, Basically, we've got the flat countertop, it was in the classroom, and an inclined plane like this. The inclined plane had some height to it, so it was like this thick metal track that the cart would roll down. The cart started off up here. Oops, pretend that those wheels are touching the track. The cart started up here and not moving. One of the pictures I share is of a meter stick so that you can kind of figure out this height that it started off at. Later, the cart rolls down the hill. There's a video clip. It's not the best clip. I was trying to work the camera and operate the equipment, so it's not the best video clip. You don't see the whole rolling thing, but it's not that exciting. It's just a cart rolling down a hill. Later, the cart ends up way down here. And again, in that list of resources, there's a picture so you can figure out how high the cart ends at. I'm going to call that H2. So from the two heights, there's enough that you can figure out the change in height. That should help you with figuring out some gravitational energy. I don't want to give it all away, so I don't want to talk too much about it. Also, you can kind of see it in the video clip, but I've got a thing called a motion sensor. It's like a policeman's radar gun. It's a piece of equipment. It could sit at the top of the track or it could sit at the bottom of the track, and it basically records where and how fast the cart is going as it slides down the hill. I've included, so the sensor thing was connected to a computer. The computer recorded all the data and put it in a spreadsheet. I've included a spreadsheet so you can get a list of data for how fast this cart was going at every instant as it went down the hill. Those are linked in spreadsheets. Open the spreadsheet and look through the data. There's different ways to do it, but you can basically figure out how fast the cart was going when it got to the bottom. Also given in one of the pictures is the mass of the cart. So you'll have a number for how many grams this thing weighs. So knowing the two heights by looking at your picture and sort of reading a meter stick, knowing how fast the cart's going at the bottom of the incline by opening the spreadsheet and figuring out a way to sort through that data, look at that data and figure out how fast it was going at the bottom. I've kind of broken it down into 4 things I want you to figure out. So I'm repeating what I said above. Based off of that, you should be able to figure out the initial gravitational field energy it had. You should be able to figure out the final kinetic energy. From that, you should be able to figure out the energy lost. Something that might push you a little bit, so I don't want to give any hints yet. See if you can figure out the force of friction that acted on it, and see if you can find out the efficiency. A little hint here in bold. The purpose of the inclined plane was to convert the gravitational energy to kinetic. Based off of these numbers you found up here, how efficient was it at doing that? When you think you've got this one done, just give it a look over. Make sure that there's no Scooby-Doo mysteries. I can tell what you're doing and why you're doing it. I can see each of these values, so it's not like a treasure hunt for me. One little wrinkle, when we do labs, I don't like to have all 30 of you doing the exact same thing. So when I did the lab, I ran it 3 times, always from the same initial height, the same final height. It was the same basic setup, but I switched around the carts so that the carts had different amounts of friction. So just so that not all of you doing the exact same lab, if your birthday is in the first third of the year, then use this spreadsheet to figure out the speed at the bottom. If your birthday is in the middle third of the year, use this spreadsheet, it's slightly different. And if your birthday is in the last third of the year, use this spreadsheet, again, it's slightly different. Oh, and when you need the math, that's in that photo. So everything I think you need is in these resources. Think it through before you get to it. And as always, I am willing to help and give hints if you have any questions, but give her a go on your own first. Email if anything's bugging you.